Okay, let's dive into one of the most powerful and honestly, one of the most elegant ideas in all of science. We're talking about the theory of natural selection. This is the engine, the simple underlying force that creates all the incredible, just mind boggling diversity of life you see on Earth.
But you know what? We're not going to start with a boring textbook definition. Nope, we're going to start with a mystery, a puzzle that stumped naturalists for centuries. And the question is a pretty simple one. How on earth does nature create illusions so perfect they basically look like magic? Just look at this thing, the orchid mantis. This disguise, it's not just kind of close, it is so perfect with those legs that look just like petals and its incredible colors that it's actually better at attracting insects than the real flowers around it. I mean, come on. So how does that even happen? How does a creature end up so perfectly, so exquisitely engineered for its world when there's no engineer?
All right, to crack this case, we need to meet our detective. And we're going back to the early 19th century to meet a young, super curious naturalist named Charles Darwin. He was the one who set out to find the answer, even if he didn't quite know it at the time. So, the story really kicks off in 1831 on a ship called the HMS Beagle. Darwin's official job? Well, it was to collect specimens, plants, animals, rocks. But what he really ended up collecting was a whole series of baffling clues. Clues that would turn everything people thought they knew about life completely on its head.
Okay, clue number one. And it didn't come from some living, breathing creature. Nope. It came from the ground right under his feet, down in Argentina. It was like a message sent from a long-lost world.
So, down in Argentina, Darwin digs up these incredible fossils of something called a glyptodon. Think of a car-sized armored beast. And he immediately realized this extinct giant looked just like a supersized version of the armadillos that were literally scurrying around in the exact same place. It raised a huge question. Why would a ghost from the past look so much like a living creature? This was the first really big piece of the puzzle. All right, on to clue number two. This one came from a super remote, totally isolated chain of volcanic islands. Islands that would become world famous because of his visit. You guessed it, the Galapagos. And it's here that Darwin noticed something pretty remarkable about the giant tortoises. They weren't all the same. On islands where the plants grew low to the ground, the tortoises had these low, domed shells. But on islands where the food was higher up, they had these wild, saddle-backed shells and really long necks to help them reach. It was almost like each island was its own little workshop, perfectly custom designing its inhabitants for the local menu. And now for the final clue. In this one, well, it wasn't about animals at all. It was about the very ground Darwin was walking on. It was about time, and I mean immense amounts of time. Get this. He found fossil seashells thousands of feet up in the Andes Mountains. Seashells in the mountains? This was just mind-blowing proof for a new theory from a geologist named Charles Lyell. The idea that the Earth wasn't static, that it changed slowly, gradually, over these vast stretches of time. And that right there, that was the final crucial key. Because for life to change slowly, it needed that one essential ingredient, a ton of time. So Darwin heads back to England, and he's got all his clues lined up. These ancient fossils that look just like modern animals, island creatures perfectly designed for their homes, and this idea of an ancient, always changing Earth. He basically had the what was happening, but he still needed the how. And where did he find a hint? Not in some exotic jungle, but in the everyday work of English farmers and breeders. See, for centuries, people had been doing something called artificial selection. It's pretty straightforward. You just intentionally choose which individuals get to have babies in order to get the traits you want. I mean, we've been doing this forever. We pick the cows that give the most milk, or the corn that grows the biggest cobs, or, if you want a really extreme example, look at the Belgian blue cattle and that unnatural muscle. So Darwin started thinking, if we humans can change a species that dramatically in just a handful of generations, what could a force that's way more powerful, way more relentless accomplish over millions of years? And that was his light bulb moment, his big breakthrough. He connected his own observations with the ideas of thinkers like Thomas Malthus, who pointed out that populations always grow faster than their food supply, and that means there's always a struggle to survive. Darwin realized that struggle, that was the selecting force. It was the thing doing the choosing.
So he asked, what if nature itself was the breeder? And he gave it a name, natural selection. Okay, so how does this whole process actually work? Well, it all boils down to a few simple but incredibly powerful rules. It's like a logical recipe that, if you just give it enough time, can create the most amazing complexity you can imagine. Rule number one, there has to be variation. Simple as that. In any group of animals or plants, individuals are not all identical clones. They all have slight differences in their traits, right? And those differences come from their genes. A great example is this jaguar cub. It inherited a different coat color from its mother. That's genetic variation, right there in front of you. These little differences in color, size, speed, or whatever, they're the essential raw material that selection gets to work with. Think about it. If there's no variation, there's nothing to choose from, and the whole process just stops. Okay, rule number two. There is a constant struggle for existence. Life out there is tough. It's not easy. In any environment, there's only so much food, water, and shelter to go around, and that forces everyone to compete with each other just to stay alive. And here's the thing. Most organisms can produce way more offspring than can possibly survive. Way more. This overproduction basically guarantees that there are going to be winners and losers in that competition for resources. Not every single individual that's born is going to make it long enough to pass on its genes. And finally, rule number three. This is where the first two rules come together, where variation meets competition. Some of those little inherited differences we talked about give an individual an edge. It might be a tiny edge, but it's an edge in that struggle to survive and have babies. And we have a name for that beneficial trait. We call it an adaptation. So let's bring it all together with those jaguars again. In their population, there's a variation. Some have slightly larger, stronger jaws. Now that trait becomes a huge advantage when other food is scarce because it lets them eat armored reptiles. That's a survival advantage, right? We say they have higher fitness, which is just a fancy way of saying they're more likely to survive, have cubs, and pass on those genes for bigger jaws. And then, over many, many generations, that helpful trait becomes more and more common, and the whole species gradually changes. Now, the cool thing is, this isn't just some old historical theory about fossils and islands from long ago. No, this is a process that is happening right now, all around us, all the time, and we can actually watch it in action. Let's go back to those Galapagos finches. So in 1977, a really bad drought hit. It wiped out all the plants that made small, soft seeds, leaving only the big, tough ones. What happened? Well, only the birds with bigger, stronger beaks could actually crack them open and eat. And scientists who were already there measuring the finches found something amazing. After the drought, the average beak size of the birds that survived was noticeably larger. The environment literally changed the rules of the game, and in just one single generation, the whole population adapted. So here's the big takeaway. If a single drought can cause a real measurable change in a species in less than 2 years, just stop and imagine what millions of years of shifting climates, new predators showing up, and entire continents drifting apart can create. That right there is the immense creative power of natural selection. It's the simple, almost elegant mechanism that solves our original mystery, the orchid mantis, and explains the absolutely breathtaking diversity of all life on Earth.